YouTube? How you do? How you doing? It's your boy. It's your boy J O H H A B R A H A M. Oh fuck! I can't control my face. Today we're gonna look into analytical chemistry 1 hour. 1 hour. Okay. 15 minutes. There we go. Yo, somebody else just used the chat. Devoto did. Hi, Josh. Hello. Hello. Appreciate you for checking out the stream. Like I said, 1 hour. 1 hour. Just let me see how much progress can 1 hour hold. Where is it? Okay, I gotta change the name of this chat because rename Analytical Chemistry Lab Preparation. Oh man, the mouse is getting slower. I can't live with this like this. I can't live like this. So I remember the burette readings. I'm sure they're gonna show us once, like one time, how to titrate. And basically we're just calculating before and after volumes and figuring out the concentration from there. Okay. Can you start again with the procedure? Because it's... and I kinda forgot. Determination of acetic acid by NaOH titration. The experiment has 3 parts. Prepare an approximate NaOH solution. Goal: make about 0.1 molal or NaOH that will later be standardized. Procedure: weigh 1 to 1.3 grams. Yeah, that's the case of NaOH, right? Quickly rinse pellets to remove surface carbonate. Dissolve the pellets in 50 ml DNS water. Transfer into a colorimetric flask. Whisk fill till the mark. Mix thoroughly. Mass of NaOH used. Preliminary titration. Estimate how much NaOH is needed for the endpoint. Fill the HAC sample flask to 250 milliliters with deionized water. Rinse a volumetric pipette with a little HAC solution. Pipette 25 milliliter HAC into the Erlenmeyer flask. Erlenmeyer flask. Add 2 drops of phenolphthalein indicator. Rinse and fill the burette with NaOH solution. Rinse the volumetric pipette. Okay. Add 2 drops of phenolphthalein indicator. Rinse and fill burette with your NaOH solution. Record initial burette reading. With your NaOH solution, there should be an amount, right? 25 milliliters, if I understand. Record initial burette reading. Titrate while swirling the flask. Near the endpoint, add an NaOH dropwise. Stop when a faint pink color remains. At least 30 seconds. Record final burette reading. Initial burette reading, final burette reading, NaOH volume used. This record is only an estimate. Standardization of NaOH using KHP. Determine the exact concentration of NaOH. Accurately weighed 0.3 to 0.5 grams of KHP. Transferred to Erlenmeyer flask. Add about 75 milliliters deionized water and dissolve completely. Add 2 drops of phenolphthalein. Fill burette with NaOH. Record initial burette readings. Titrate to the same endpoint. Faint pink persists more than 30 seconds. Guess who's back? Sandstan, let's go. How you doing? You know what? Just so when you came to the stream, I just got reminded that I need to paste the link onto the Discord. Yep. Doing good. Okay. Making some homemade bread right now. Oh, okay. So I'm guessing you're starting from scratch, like like mixing the flour into the oven, yeast, flour, salt. Oh, okay. Oh yeah. I don't know why, but making bread like that, it's just better. Just gives you more control. Spanish milk bread. Okay. I'm guessing that's like the classic form of bread, right? I should also try cooking bread because it's pretty easy from what I heard, but you still need to know how to. Oh, okay, this one. Oh shit. I was. Okay, I thought it was just a cube type of classic wheat bread. Oh yeah. Bread is just good. My mouse is not working properly. It makes it in a cube. So the final product looks like a cube. Oh wait. I gotta go though. Oh, okay. Well, appreciate you for checking out the stream. Just so you said the cube part, I just reminded me there's a bread called French toast or something that looks like a cube. Well, respect for checking out the stream. Yeah. Oh. Yes. So we wait in KHP transferred to the flask, 75 milliliter DNS water dissolved completely, 2 drops of phenolphthalein. Fill burette with NaOH, record initial burette reading, titrate to the same endpoint. Again, I'm guessing the amount of NaOH solution you're using is 25 milliliters, right? It's not mentioned. What? Record the KHP mass, initial burette reading, final NaOH volume used. Record final burette reading. Repeat until at least 3 consistent titrations are obtained. Calculate the exact NaOH concentration. Determine acetic acid concentration. Okay. Okay, I just noticed that the NaOH solution that needs to be used here is not to be used here. The volume for that is not mentioned, so I'm guessing it's same as the HAC with 25 milliliters. Fast, fast, fast. I know I don't have time to waste. Come on. It's not a hard experiment. Come on, come on. You keep adding NaOH until the endpoint is reached. The volume of NaOH used is a result of titration, not something you choose beforehand. What? What? Okay. So the NaOH volume that we add to the burette is not important as long as the volume added is noted. So my next doubts would be about the chemical equations involved where the NaOH solution, when comes in contact with HAC, how it's gonna behave, and the same for the addition of 2 drops of phenolphthalein. I feel like there is a little bit hair that I forgot to shave right here. Is it noticeable? I don't think so. Nah. 15 minutes. And I need you to explain why are we doing this titration for the NaOH concentration using both HAC and a solution. Again, KHP, what's that what it's called? Potassium hydrogen phthalate, yep. Also, why is the HAC concentration need to be determined? Shut the fuck up, I don't care. What happens when NaOH is added to HAC? Acetic acid is a weak acid. NaOH is a strong base, dissociates completely. Hydroxide ions react with acetic acid or equivalently. Notice 1 mole of HAC reacts with 1 mole of NaOH. This 1:1 ratio is the whole reason the calculation is easy. What's happening during the titration? Flask contains mostly acetic acid. Solution is acidic. Phenolphthalein is colorless. As NaOH is added, acetic acid is neutralized. pH slowly increases. At equivalence point, all HAC has reacted. By adding a tiny excess of NaOH, solution becomes slightly basic. Phenolphthalein turns pink. That pink color tells you have passed the neutralization point. Phenolphthalein is not a reactant, it's only an indicator. Think of it as a pH sensitive dye. It changes color roughly around 8.2 to 10 pH. Acidic solution colorless, basic solution pink. The amount does not need to be precise because it's not being consumed. Fuck, there's no water. Gotta get some water. Fuck. I need the seats tall. I need the seats tall. Buh. Problem. You prepared NaOH from pellets, but NaOH is bad primary standard because absorbs water. The concentration you calculate from the weight and NaOH is only approximate. You might think you made 1 mole. Really, it might be okay. You don't know exactly, so what does KHP do? KHP is a primary standard. That means very pure, stable, exact molar mass does not absorb water significantly. You can weigh KHP accurately and know exactly how many moles you have. Then KHP plus NaOH product 1:1 using exact KHP mass measured NaOH volume. You calculate the true NaOH concentration. Now your NaOH is known accurately. Why did I read exactly? There's no such word exactly there, but I read exactly. I think the K kinda made it look like the X for exactly, but there's no E. Fuck. Okay. I'm not gonna waste my time. Why determine HAC concentration? Because HAC sample is unknown. The instructor gives you an acetic acid sample and asks how many acetic acid is in here. This is an analytical question. The purpose of the experiment is not really to study NaOH. Determine the concentration of acetic acid in the unknown sample. Oh. NaOH is just a measuring tool. What? Prepare NaOH, approximate concentration, use KHP, exact NaOH concentration, use exact NaOH concentration of unknown HAC. Okay. Okay. It looks like we could have done this with KHP itself. I don't see the point of using NaOH here. Oh, both are acids. Okay, acid-acid titration don't give a useful neutralization reaction. You need a base to neutralize an acid. Okay. Exactly 25 milliliters of used volumetric pipette of HAC sample are placed in a titration flask. 2 drops of phenolphthalein solution are added and titration with NaOH is started. The end point is reached when the red color remains for more than 30 seconds. So, wait. Okay. I'm starting to get it, but I need to see how the math is done in between. So can you make some sample values, or can you just show how the experiment is gonna look with sample values and calculate the final result using this sample values. Wow, what the fuck is this? ChatGPT keep on adding shit. Standardization of NaOH with KHP, mass of KHP, molar mass of KHP, volume of NaOH used is 21.35 moles of KHP. So yeah, the mass divided by molar mass. Number of moles, yeah, stoichiometry 1:1, so it's exactly same amount of number of moles of NaOH. NaOH concentration, volume of NaOH equals 21.35 milliliters. Concentration 0.968 mole per liter. So mole divided by volume. Number of moles divided by volume. Yep. Concentration. And acetic acid titration unknown. Volume of HAC 25 milliliters. Volume of NaOH used 18.62 milliliters. NaOH concentration is 0.968. That's from here, okay. Step 1, moles of NaOH used. Number of moles of NaOH used. How do you get that? What made you get that? 968. That's the concentration into okay, this volume. Okay, from that you get the number of moles of NaOH used. Stoichiometry is again 1:1, so the number of HAC used is also the same. Then we divide the volume of HAC used with the number of moles of HAC we got using 1:1 ratio of NaOH used. Convert what your lab wants. Density 1 gram per milliliter. Typical assumption unless stated otherwise. Molar mass of acetic acid is 60.05 grams per mole. So you convert from concentration. That's that. What did you get now? Convert to percentage. So you convert to gram per liter. What is gram per liter? Fuck. What was gram per liter? Percentage. Weight to volume. 4.3 grams per 100 milliliter, 1000 milliliters. So 0.433 percentage of what? Acetic acid? Spanish milk bread, really? Result, come on. Could you explain what the confidence interval, and I did not see you use that. What your 95% confidence interval actually says. If you repeated the whole experiment many times, 95% of the calculated mean values would fall under this interval. In practice, you are 95% confident the true values within this range. Why don't you see it in previous example? I only showed single trial calculation. So CL only appears on the final reporting stage, not per titration. What you actually do in your lab. Let's say you got these percentage HAC results. Okay. You calculate the mean, standard deviation. This means this measure spread precision. You calculate how far deviate from the mean. S equals 0.0036. Where did you get that 0.0036? Where did you get that value? Okay. Can you redo this again with multiple measurement, possibly like the experiment I have for measured values, and do this again with the confidence interval included result. I did not understand how you got this value. 15 minutes. Nope. Okay. For 4 times divided by 4. Mean average equals, okay. Standard deviation, this is what confused you. Formula xi minus x dash. So individual result minus the mean square sum. Okay. Okay. So you get this as the sum of square, that's divided by n minus 1. Standard deviation is about 0.0029. Again, I don't think you have to change the values now. Final standard deviation. This is where earlier 0.0036 type values comes from. Just slightly different sample numbers. 95% confidence interval. Degrees of freedom equals 3. T equals 3.182. Where do you get the 3.182? Huh? Where do you get that? How? Okay. I'm a bit confused on the degree of freedom. And the T equals value. How did you get it? You measured n equals 4 values. First you compute the mean. That mean is then used in every deviations calculation. So one constraint is used up by calculating the mean. That leaves, fuck, just a minute, gang. You measure n equals 4 values. First, you compute the mean. That mean is used in every deviation calculation. So one constraint is used up by calculating the mean. That leaves with any n minus 1. So t of f equals, if you know the mean and 3 of the values, the fourth value is no longer free. It is forced to satisfy the mean. This is why only 3 independent pieces of the information remain, 3 degrees of freedom. What the t-value is. The t-value is not calculated from the data directly, it comes from the t-distribution table. Fuck, it depends on confidence level, degrees of freedom. If you look up confidence equals 95% from a standard t-table. Okay. Wait. Standard t-table. But I thought you get the 95% confidence value from again, the t-value is only obtained from the table where you know the confidence value 95%, but I thought you'll only get the 95% at the end. I don't. Can you also let me know if that 95% that we get as part from the results, or is it a requirement from the question? Like, can that number 95 change according to how I proceed or the values I get from as part of the experiment. Getting distracted. I can feel it. I can feel me getting distracted. Okay, so first preliminary test titration of HAC sample. First, an approximate 0.1 molal. Mm, if I see this, I should read it like 0.1 molal. Molar? Okay. 0.1 molar NaOH solution with 1 to 1.3 grams of NaOH beads, which are carefully cleaned with water to remove the carbonate layer, and then dissolved in a 50 milliliter water in a 100 milliliter beaker. The solution is transferred to a 250 milliliter volumetric flask, which is subsequently filled up with deionized water. Now, to get familiar with the equipment and technique of the titration, a preliminary acid-base titration is accomplished. For this flask containing the sample solution is filled up to 250 milliliters in deionized water. Exactly 25 milliliters of HAC sample is placed in titration flask. 2 drops of phenolphthalein solution For this flask containing the sample solution is filled up with the 250 milliliter deionized water. 25 milliliters of HAC sample is placed in the titration flask. Titration flask, if I understand, it's the one with the small lid but big base. 2 drops of phenolphthalein solution are added to the titration with and titration with NaOH prepared before it's started. The endpoint is reached when the red color remains for more than 30 seconds. Okay, more than 30 seconds. Determination of the exact concentration of NaOH solution. Next, before the actual determination of HAC sample can be performed, standardization of a NaOH solution is required. Therefore, 0.3 to 0.5 grams of potassium hydrogen phthalate, a primary standard, are weighed exactly, transferred to a titration flask, and dissolved using approximately 75 milliliters. Weighed exactly, transferred to a titration flask, and dissolved using approximately 75 milliliters deionized water. 2 drops of phenolphthalein solution are added and titration with NaOH is started. The endpoint is reached when the red color remains for more than 30 seconds. The process should be repeated until 3 consistent results are obtained. So my doubt is 15 minutes. God damn it. How long was I streaming? It should be 1 hour. I need to make sure it's 1 hour. That's 45 minutes. Okay. I got 15 more minutes. Come on. 15 minutes. Come on, brain. Do something. Here, this process is repeated 3 times, and each time do we have to measure KHP and fill in with the 75 milliliter water. I guess so, yep. Okay, so if I am a little bit smart, I could measure the KHP values already. But is it bad if I measure the values? Is it gonna, like, oh, the KHP is gonna oxidize itself or some shit? So is it gonna be okay if I measure KHP 3 times, or separate the KHP in one try itself, but I don't know if it's gonna oxidize or something if it's kept in open air? No, I meant measuring and separating the exact value they for the experiment 3 times, so I don't have to measure, have to physically go and measure every time after the titration. Titration. My spelling is off. Yes, that approach is allowed and commonly done, but only if you do it correctly. Yeah, put them into 3 separate flasks, then titrate one of them after other. Again, that's not my question. I don't know if I could get 3 flasks. Oh, it's stable in air. Okay. So I think that's good. Determination of the exact concentration of HAC in the sample solution. Exactly 25 milliliters of HAC sample are placed in the titration flask. 2 drops of phenol phthalate solution are added and titration with NaOH is started. So from what I've seen here, so from what I have seen here, only the titration between the NaOH and the KHP is done 4 times. The others are done 1 time. The starting was just a sample, right? How many times each part is done? Preliminary HAC titration 1 times. NaOH standardization with KHP 1 time. Also repeated typically 3 to 4 times. It's not said here. It's not mentioned though. but the HAC is not mentioned, like the repetition. I need to ask that in the lab. Try. I'm almost getting it. Now I need to start writing. Start with the writing process and one person told me that it doesn't matter if you don't have a lab journal, but I still have a lab journal, so I'm gonna use it. No, I'm gonna use this page. And fuck. Chemistry. Good enough. First experiment. Determination of percentage of acetic acid. I should change the camera setup, but I'm thinking, what is the next thing I'm gonna do after this? Like I got like 5 minutes. After this, I'm gonna eat something because I'm a little bit hungry. I'm gonna eat something, then I'm gonna continue with inorganic chemistry. So for inorganic chemistry, I don't need to change the camera setup. So you know what? No, I need to change the camera setup for inorganic because I'm gonna be writing. No more reading. Read, write. So we're gonna change the camera setup. Writing. Oh shit. Oh shit. Oh wait. Just a minute, gang. We gotta change a little bit on the setup because it's not in the perfect world. Okay. Good enough, good enough. No. No, wait. Fuck. My stupid ass brain did not calculate for that. There we go. It's too tall, maybe. There we go. We got back to the OG setup. But it's not correct. And it's a bit... wait, that's the table, right? We need the table. The cable is not long enough and I don't have time to waste on arranging this. I'm sorry, bud. I'm gonna have to take that off. It's charging. I don't want to see the table, not gonna lie. I don't want to see this part. Let's end it till here. We gotta level it, cause and yeah, that's good enough. Is it too much? Kinda too much space. But hey, looks cool. Too much cables. Oh shit, I'm gonna interfere a lot, right? Determination. Determination of the percentage of acetic acid in a solution by titration with NaOH. Okay, gang. It's 1 hour. I'm gonna be right back. We're gonna start with inorganic. Peace.